Break-even analysis. You know, if you're starting a new product or project, you might want to know where you break even, start to make a profit. On a graph of, say, quantity versus dollars, you would have fixed costs, lease, salaries, stuff that's going to be the same regardless of the amount of output. Let's add to that variable costs, such as a material per unit, labor rates figured per unit, and we'd add that to the fixed cost, getting a total cost. Notice that the slope here is the variable cost. Let's now overlay the revenue, which would be the price times the quantity, and notice here the slope is the price. And where they cross over each other, we call that the break-even. And we can figure that in units of quantity as well as in dollars. And it's time for an example. Let's say a firm has $120,000 in fixed costs. Overhead, lease, salaries, utilities, and they have $4 in materials used per unit. And let's say they pay $30 an hour in labor, and that produces 5 units per hour. So thus the variable cost is that $4, and the 30 divided by the 5, which is 6, making a total of $10 a unit. Well, let's see what the quantity and revenue break-even would be if they charged a $12 price. Notice it's got to be above that $10 variable cost. Well, let's see, the quantity break-even would be that 120 grand divided by the profit, that's here 12 minus the 10, or $2 a unit, which works out to be 60,000 units. We take that number, multiply it times the price, and we get $720,000. Noting this is just merely a feasibility study. We haven't talked about how to maximize profit. But wait, there's more. Let's try a different price. Here, it's the red line on this graph of a second example. And let's say we raised it. That'd make the break-even a little bit smaller in both regards. Trying a $15 price now. That's a $5 profit per unit. And we divide that in again to the fixed cost of 120 grand. We now get 24,000 units. And a revenue break-even of 360 grand. Notice that the revenue break-even is exactly half, but it required a $3 gain versus the $2 previous. In an advanced analysis, one can figure out a profit maximizing price by looking at something called the elasticity of demand, the change in quantity over the average quantity, divided by the change in price over the average price. Here I'm calling it in. The economists use the Greek letter eta, for elasticity, and they write it differently, but it's the same mathematically, and in either case they use the positive version. Well, let's take an example. At $16 you sell 8 grand, but at 14 you sell 12 grand. A difference of $2 in price and 4,000 in quantity. Well, figuring out the elasticity turns out to be 3. And with a variable cost of $10, you plug it in and you get a optimizing price of $15. With a variable cost of $8, you'd only charge $12 for a maximizing price. Keeping you up to date with Dr. C.